So, start. Okay, so your solar system consists of an array, ground mount array, out in the backyard.
Yeah.
That converts sunlight to direct current electricity. That power is conducted through cable from each individual panel, grouped up into several strings in series of panels, and then those are all collected and fed into the inverter. All those conductors are housed in conduit that come into the inverter on the side here.
Mm-hmm.
It's pointed DC conduit from array.
Mm-hmm.
There is a point of disconnection there. If you wanted to isolate the array from the inverter, it's underneath the bottom of the inverter, and it's a dial. You just rotate it 90 degrees to turn it off, or turn it back the opposite direction to turn it back on.
Okay.
There is a screen here that displays, just like this, information, and you can scroll through different menus, but the standard menu is just telling you how much power, instantaneous power, the sunlight is generating on that array. So if we've got intense sunlight, we might be creating 9,000 watts. On a normal day, we may be around 7,000 watts.
Okay.
On a dim day, we might be only 400 watts.
Got it.
So if we sustain that wattage over a period of time, we create watt hours or kilowatt hours of energy. So power is instantaneous, energy is power over time. So once it's converted to AC, it's actually sensing what's going on with the grid and matching the voltage and the frequency or waveform of what's going on in the grid. The grid's electricity changes all the time.
Mm-hmm.
It's just like a water pipe feeding.
Yeah, it's fluid.
Yeah.
I mean, not really, but
well,
obviously.
It's flowing electrons.
Yeah.
Okay, and that varies all the time. So this inverter's always working and always pinging or sensing what's going on in the grid and adjusting what it's creating out of that DC power. There are three little handles here that are screens. This is an actively cooled inverter. When it converts DC to AC, there's a little bit of heat loss. Maybe 3% of the energy is exhausted in heat through that transformation process. And if you were in, say, a wood shop, if this was located in a dusty area, you might want to pull those out once a year and blow them off. In the outside atmosphere, there may be bugs impinged on it, and that's about it. So that's a point of inspection, not necessarily servicing, but inspection by the owner. Once these electrons are converted to AC, they drop down through a conductor housed in a protective conduit down into the ground and along this trench buried about 2 feet down.
Mm-hmm.
And this is visible, and I'll come back and backfill where it settled. It was very muddy, and it always seems that there's never enough soil to backfill a hole once you dig it out.
Yeah.
But we'll find some and bring that up to match grade around the outside of it. So those electrons then come up through this conductor here, or conduit, and here's another point of disconnection, an AC disconnect switch required by PUD. Some utilities like Puget Sound Energy or Seattle Light have decided not to have this extraneous piece of equipment in here. But that's a point where the PUD can come along and isolate the power coming into the system if they were to want to work on their side, which is up to this point right here. From this point on, this is a net meter that registers how much energy has gone into your property and what's been received from your property. And that's where the billing happens. The net difference between the two, if they've sold you more than what they've received, it'll show as billable energy on your PUD bill.
Okay.
If you have a net export, it's going to show up as a credit, which you can then pull off during the night or during the winter months when we're not creating so much energy. So there's no cash transfer for your banked up electricity. It is just a banking of electricity. And that will, if you have a surplus left on the grid or left on the PUD account, they'll reset that once a year, and it's usually in April. I think they should pull it back to like the end of February, because March and April are generally we're starting to surplus energy again. So
Okay.
Just
that's kind of where
something to be aware of. We need to change that is set up by law on RCW, Revised Code of Washington. We need to revise that now that we're solar smart. We set that up like 10 years ago when there wasn't a lot of energy or PV on the grid. Now we're a lot smarter. So those electrons that come up through this isolation switch are then registered. See it spinning? We're making power today. So that shows 203 units, and that unit of measurement is kilowatt hours, and it's spinning, and that will only go forward. So that registers the total amount of energy since it came online, which was the 9th of February 2016, and it's rocking. It's making a lot of power right now. So this should click off. We should see more on here by the time we're done talking.
Interesting. Okay.
So once it gets registered, then again it goes through a conductor to a PV circuit breaker. This is where it enters the... It's a 60 amp circuit breaker, and the maximum amount of current flowing through this is expected to be less than 42 amps. So we have overcurrent protection that is 1.25, at least greater than the 41.7 that we expect to see.
Okay.
So that's another point of disconnection. All along here, these little circuit breakers are like valves in a water line. They're points of isolation if you wanted to work on equipment in between those points of isolation. So once we go through the circuit breaker, it's now eligible to be used. Those solar electrons are eligible to be used within the house, and that's where they first get distributed. So there is a conductor going to the house service panel, and any loads in the house receive those solar electrons. Any surplus then, it's like again, like water. So these are small water lines, big water line coming in, small going to the house. Any surplus then gets split and then goes out to the PUD.
Back to the
yes,
city.
To the
PUD. Yeah.
PUD, yes. And it's going to be registered on that meter. And that's the last point of interaction that these electrons have. Then it goes out to their equipment. There's a transformer sitting on the pole out in the street.
Okay.
And there's a trench that's been buried for years from here right through pretty much direct line. And we had utilities locate where that was.
Oh, okay.
And it was sprayed with red, meaning red is power.
Red is hot.
Orange is phone.
Okay.
And that was a parallel trench also for phone coming in. So that's basically it. So when you get your power, well, Jared's actually getting the power, or the power bill's now coming to you.
It is.
Okay, so when you get that power bill, you might want to just have Jared come out and read close to the day that the power meter is read by PUD. He won't know when they're coming out to read, but only when you receive the bill are you going to know the date that they actually came out. So it's roughly 30 days in between, and it's going to be routinely about the same date every month. So look at historically what days they've been coming out, and he can come out and just do a double check, just to make sure that PUD's reading the meter correctly.
Okay.
And that you're being credited the amount of power that you should be. So going back to prior to solar coming in, Jared had a historical energy use distributed through the year, month by month, and it changes. Typically we're using more power in the winter months, less power in the summer months. We have no air conditioning loads here, and I don't believe he's irrigating, and he doesn't have an on-site well. You're hooked up to PUD water, so that it would stand to reason that energy loads would be higher in the winter, less in the summer. Total electrical consumption in the house is equal to what's been delivered from PUD plus what's been delivered from your solar. Those are the two sources of electricity, minus what's been sold back, or not necessarily sold back, but
stored back,
received by the PUD.
Received by, okay.
Yeah. So you don't have to remember that. Just understand the concept, and if you ever need it, Here's
It's all
a
right
quick,
there.
quick sheet of things that are applicable to the system.
Great.
So, things to remember. Look for your Department of Revenue form. They're going to mail you a letter saying that they've received our application and they've assigned you a tax ID number. That verifies that they've got you on record to receive kilowatt hour readings once a year from Clallam PUD, and they'll disperse money to you for the next 4 years. Each June 30th, we want you to read this meter.
Okay.
And there's redundant information on the inverter, but this is the important one.
Yep.
And if you can't read it on June 30th, read it a little bit before and a little bit after, and then interpolate. So you can read it the weekend before, and then the weekend after, 7 days transpired. You know, if it
Wherever that
falls
midpoint
on,
roughly is.
Yeah,
Got it.
if it's 6 days into it and then 1 day before, then you can go, you know, 1/7, you know, just interpolate. Okay. We're estimating on an average year that this is going to produce about 7,600 kilowatt hours. Last year, if this thing was online, I'd expect to see 40% more because we had 40% more sunshine. You're now a farmer, and farmers know that their crops aren't uniform year after year. They have, in low sunshine years, or high rain years, they may have lower yield, and in super sunny years, like last year, we had a super dry and sunny March and April, so we got 40% more energy last year.
Okay.
The year before, 25% more energy because only April was stellar. March was a normal March. I recently visited a system that was put in October, inspected it last month, and it was reading 15% less than what I expected.
Mm-hmm.
So remember how much rain we received in December?
Well, yeah, it's been records,
It really
right?
showed in our PD
Yeah.
production. So the distribution through the year is roughly 75% of our power is made from March 15th through September 15th. Only 25% the remaining 6 months. So if we have a low production winter, it's not really going to impact the overall annual as much as a low sunshine summer. So we still may make it up. Okay?
Okay.
So if my annual estimate is assuming 10% greater or more from the average, 40% is unusual. We've had El Nino happen. I think some climatologists are calling it the blob out there. It's a warm ocean which is confounding our normal weather patterns. So I'd expect to see maybe 8,500 to 6,500 range. And if you're outside of that range, give us a call. It might be a system, it may be the system telling us that we've got something that we need to correct.
Okay.
But typically it's just weather. These are really bomb-proof, hands-off type systems. I'd expect the modules to keep producing at their new rate. Those are probably putting out 335 watts per module, and I expect to maintain that for next 10 years, and then maybe for the next 50 years to be equal to or slightly less than their nominal 327 watt range. The inverter has a 10-year warranty extendable out to 20 years, and those mathematicians that determine length of warranties, I'd expect that inverter to last at least 21 years. So you can expect something to happen 21, 22 years from now, replace the inverter, and then you're good for another 20,